Hello. In part 1, I have explained how to solve stagecoach problem using dynamic programming. In this video, I am going to explain how to solve cargo loading problems using dynamic programming. Let's take first what are cargo loading problems. So cargo loading problem is an optimization problem in which a logistic company has to take a decision regarding the loading of items subject to its weight or volume so that the return to the company will be maximum. Let's take an example. Alpha Logistic Company has to load a cargo out of 4 items whose details are shown in the table below. The maximum weight of the cargo is 7 tons. Find the optimal cargo loading using dynamic programming method such that the total return is maximized. Here in the table 4 items are given. Their weights are 2, 1, 4 and 3 tons, and if they carry out, the returns are 1000 rupees, 4400 rupees, 2100 rupees and 1400 rupees per item respectively. Now, whenever there is the problems of cargo loading, these problems are divided into number of stages with respect to the items. So in the stagecoach problem, each item is treated as a stage starting from stage 1 to stage 4. So this will be stage 1, stage 2, stage 3 and stage 4. Now here the maximum weight of the cargo is 7 ton. So the maximum weight which can be carried out is 7 ton. So the weights allocated to the alternatives in each of the stages are 0 and multiples of the unit weights. Multiples of unit weights. So if we consider the item 1, if we consider item 1 can be carried out maximum 3 quantity. So if we take the 3 quantity of item 1, its total weight will become 2 multiplied by 3 equal to 6 ton. Now if I take 4 quantity, it will exceed that limit, 7 ton. Now, as I told, the cargo loading problems are divided into number of stages and each stage will be each item. So, let's solve stage 1 where only item 1 is considered whose weight is 2 ton. Now in stage 1 there are 4 alternatives. These 4 alternatives and the weight allocated to these alternatives are, first here will be 0. In the second alternative multiple of 2, that will be 2. In the third alternative it will be multiple of 2, so 0, 2, then here it will be 4. And in the fourth alternative it will be 6. The state variables will vary from 0 to maximum 7 because the cargo limit or the cargo carrying limit is given 7 unit. So in every stage the state variable will be ranging from 0 to 7. So the stage variables are 0, 1, 2, 3, 4, 5, 6 and 7. Now the allocated weights will be, in the first alternative it will be 0, in the second alternative it will be 2, in the third alternative it will be 4, in the fourth alternative it will be 6. Now recursive function for the stage 1 will be allocated weight divided by 2. So this is with respect to this, with respect to weight of the item, multiply by 1000. Now 1000 it is the return value. Okay. Now let us consider state variable x1 equal to 0. At the same time the allocated weight is, let us consider 0. So when we consider state variable 0 and when we allocate weight 0 of item 1, so in that case return will be 0. So this value 0 will be obtained if we put allocated value 0, divide by 2, multiply by 1000. 0. Now here we cannot take allocated weight 2 because it will exceed this limit. Here we have considered state variable value is 0. So after 0 we cannot consider allocated weight 2, 4 or 6. Okay. So the best recursive or return function value will be 0 with respect to alternative 1. Now let us consider the value of state variable is 1 ton. At the same time weight allocated is 0 ton. So when the allocated weight will be 0, so 0 divided by 2 multiply by 1000, the recursive function value will be 0. Now here again we cannot consider this weight as this 2 allocated weight because here we have considered maximum value of state variable is 1 ton. So the best recursive function value will be 0 with respect to alternative 1. Now let us consider the value of state variable x1 equal to 2 ton. So with respect to 2 ton, when we allocate weight 0, the value of return function or recursive function will be 0. Now when we consider or when we allocate 2 weight, so in that case the return value will be 1000. So allocated weight 2 divided by 2 multiply by 1000, it will be 1000. Now here we cannot allocate weight 4 because it will exceed this limit that we have considered 2 ton. Now amongst the two recursive function values 0 and 1000, the best recursive function value is 1000 with respect to alternative 2. Now let us consider the value of state variable x1 is 3 ton. With respect to 3 ton, when we allocate weight 0, the recursive function value will be 0. Now when we allocate 2 ton weight, the recursive function value will be 1000. Now beyond 2 we cannot allocate weight 4 because it will exceed this limit 3. So amongst 0 and 1000 recursive function value, the best recursive function value is 1000 with respect to alternative 2. Now let's consider the value of state variable x1 equal to 4. Now when we allocate weight 0, the recursive function value will be 0. When we allocate the value 2, the recursive function value will be 1000. Now here we can consider the weight 4 or we can allocate weight 4 ton. So when we allocate 4 ton weight, the recursive function value will be 4 divided by 2, that is 2 multiplied by 1000, it will be 2000. Now we cannot allocate weight 6 because it will exceed this limit. So amongst 0, 1000 and 2000 recursive function values, best is 2000 with respect to alternative 3. So similarly, when the state variable is x1, state variable x1 equal to 5, the recursive function values with respect to allocated weight 0 will be 0, 2 will be 1000, for 4 ton it will be 2000. Now we cannot allocate weight 6 because it will exceed the limit 5. So amongst 0, 1000 and 2000, the best recursive function value is 2000 with respect to alternative 3. Now when we consider x1 equal to 6 ton, the recursive function values with respect to allocated weights 0 will be 0, allocated weight 2 will be 1000, 4 it will be 2000, for 6 it will be 3000. So 6 divided by 2 multiplied by 1000, it will be 3000. So amongst 0, 1000, 2000, 3000, the best recursive function value is 3000 with respect to alternative 4. Now when we consider x1 equal to 7, the recursive function values with respect to the different allocated weights will be 0, 1000, 2000 and 3000. So amongst these values, 3000 value of recursive function is the best one with respect to alternative 4. So in this way the stage 1 can be completed. Now let's move towards the stage 2, where the item 2 along with item 1 will be considered for the optimization. Now in the stage 2, the recursive function will be allocated weight divided by weight of the item 2 multiply by a return of the item 2, that is 400, plus the best recursive function value obtained in the stage 1 with respect to the corresponding state variable. So what is this? This I will explain later when we consider the state variables, and with respect to state variables when we determine the recursive function value. So at that time I will explain. Now this table, it shows the best recursive function values with respect to the values of state variables ranging from 0 to 7. So these values are obtained in the stage 1. Now in the stage 2, again the state variables are same, 0 to 7, 0, 1, 2, 3, 4, 5, 6 and 7. Now there will be the alternatives ranging from 0 to 9, 7. So 0, 1, 2, 3, 4, 5, 6 and 7. So these values are multiple of 1 because unit weight of the item 1, the weight of the item 1 per unit is 1 ton. So that's why 0 to 7 total alternatives will be 8. Now when we consider x2 equal to 0, with respect to 0, when we allocate weight 0, the value of the recursive function will be allocated weight 0 divided by 1 multiplied by 400. So it will be 0 plus the value of best value of recursive function for x2, that is 0, minus allocated weight, that is 0. So f1 for 0 is 0. So 0 plus 0 equal to 400. here we cannot allocate weight 1 because it will exceed the limit of x2. Now let's consider the value of x2 equal to 1 ton. So with respect to 1 ton, when we allocate the weight 0, again the value of the recursive function will be 0 plus 0 equal to 400. Now when we allocate weight 1 ton, the value of the recursive function will be 1 divided by 1 multiplied by 400, so it will be 400 plus f1 of, now x2 is 1 minus allocated weight is 1, so 1 minus 1 it is 0, so f1 for 0 in the stage 1 is 0, so the value of the recursive function will be 400 plus 0, so it will be equal to 400. Now here we cannot allocate weight 2. Now amongst these two alternatives, amongst these two alternatives 0 and 400, the best value of recursive function is 400, is 400 with respect to alternative 2. Now let's consider the value of x2 is 2 ton. So with respect to 2 ton, when we allocate weight 0, the value of the recursive function again it will be allocated weight divided by 1, so allocated weight is 0 divided by 1 multiplied by 400, so it will be 0 plus f1 of x2, so that is 2 minus allocated weight 0, so f1 of 2, this value is 1000, so 0 plus 1000 it is equal to 1000. Now with respect to x2 equal to 2, when we allocate weight 1, the value of the recursive function will be allocated weight 1 divided by 1 multiplied by 400, so it will be 400 plus f1 of x2, that is 2 minus allocated 1, that is 1, so 2 minus 1 it is f1 of 1, it is 0, so 400 plus 0 it is equal to 0. Now when we allocate weight 2, the value of the recursive function will be 2 divided by 1 multiplied by 400, so it will be 800 plus f1 of x2, that is 2 minus allocated weight, that is 2, so 2 minus 2 it is 0, so f1 of 0 it is 0, so 800 plus 0 equal to 800. Now we cannot allocate weight 3. Now amongst these three values of the recursive functions, 1000, this one is 400, so let me check it, let me correct it. So amongst these values 1000, 400 and 800, the best value of recursive function is 1000 with respect to alternative 1. Now let's consider x2 equal to 3. When we allocate weight 0, the value of the recursive function will be 0 plus 1000. So by following the same recursive function, this value can be obtained. So the procedure will be same as I have used to calculate these values. So the value of the recursive function will be 0 plus 1000, it will be 1000. For the allocation of weight 1 ton, the value of the recursive function will be 1400. For weight 2, value of the allocation, value of the recursive function will be 800. For 3 ton, recursive function value will be 1200. So the best value of recursive function is 1400 with respect to alternative 2. Now when we consider x2 equal to 4, for 0 allocated weight, the recursive function value will be 2000. For allocated weight 1, recursive function value will be 1400. For 2, it will be 1800. For 3, it will be 1200. For 4, it will be 1600. So best value of recursive function is 2000 with respect to alternative 1. So similarly, for x2 equal to 5, the various values of recursive function will be 2000, 2400, 1800, 2200, 600 and 2000. Best value of recursive function will be 2400 with respect to alternative 2. Now for x2 equal to 6, the values of recursive functions for the various allocated weights are 3000, 2400, 2800, 2200, 2600, 2000 and 2400. The best value of recursive function is 3000 with respect to alternative 1. 3000 with respect to alternative 1. Similarly, for x2 equal to 7, the values of recursive function for the various weights allocated are 3000, 3400, 2800, 3200, 2600, 3000, 2400 and 2800. The best value of recursive function is 3400. This 3400 with respect to alternative 2. So in this way, the stage 2 is completed. Now in the stage 3, item 3 will be considered along with items 1 and 2. The weight per unit of the item 3 is 4 ton. The return value is 2100. So let's solve stage 3. Now for the stage 3, the recursive function value is, or recursive function is allocated weight divided by 4, this 4, multiply by 2100 plus f2 of x3 minus allocated weight. So this is the best recursive function value obtained in the stage 2. So this will be x3, that is these values, minus allocated weight, so that is these values. So difference between this and this, so that difference will be taken So for that difference, the best recursive function value will be taken from the stage 2. So this table represents the best recursive function values obtained in the stage 2. Now the state variables are 0, 1, 2, 3, 4, 5, 6 and 7. So this will not change, it will remain same. Now the allocated weights will be only 0 and 4, because if we take 3 quantity it will exceed the limit 7. So here we can allocate weight either 0 or 4. Now when x3 equal to 0 and when we allocate weight 0, the recursive function value will be 0 divided by 4 multiplied by 2100. So it will be 0 plus f2 of x3. So x3 it is 0 minus allocated weight, that is 0. So f2 of 0 it is 0. So 0 plus 0 it will be 0. Here we cannot allocate weight 4. So best value of recursive function will be 0 with respect to alternative 1. Now when x3 equal to 1 and when we allocate when we take 0 or when we allocate 0 the value of the recursive function will be 400. So best value of recursive function is 400 with respect to alternative n. So starting from 0 up to 3 there will be no change in the value of recursive function for the allocated weight 0, and we cannot allocate weight 4 because it will exceed limit. So when we take x3 equal to 2, the recursive function value will be allocated weight 3 divided by 4 multiplied by 2100 0 divided by 4 multiplied by 2100, so it will be 0. Now f2 of x3 it is 2 minus allocated weight 0, so 2 minus 0 it will be 2. So f2 of 2 it is 1000, so 0 plus 1000 it is 1000. So best value of recursive function is 1000 with respect to alternative 1. Now when x3 equal to 3 the recursive function value will be 0 plus 1400. So here this value will be 0 plus f2 of x3, that is 3 minus 0, so it is 3 minus 0, it is 3. So f of 3 it is 1400. So the recursive function value is 1400. Best recursive function value will be same 1400 with respect to alternative 1. Now when we allocate weight 4, when we consider x3 equal to 4 and when we allocate weight 0, the value of the recursive function will be 0. Here it will be 2000, so 0 plus 2000 equal to 2000. Now here we can allocate weight 4. So when we allocate weight 4, the value of the recursive function will be 4 divided by 4 multiplied by 2100. So this will be 2100 plus here x3 is 4 minus allocated weight it is 4, so 4 minus 4 it will be 0. So f2 for the 4, f2 for the 0 it is 0. So 2100 plus 0 it is 2100. Best recursive function value is 2100 with respect to alternative 2. Now when x3 equal to 5, the recursive function values for weight 0 will be 2400, for weight 4 it will be 2500. Best recursive function value will be 2500 with respect to alternative. For x3 equal to 6 and for the 0 allocated weight, the value of the recursive function will be 3000. For 4 it will be 3100. Best recursive function value will be 3100 with respect to alternative 2. For x3 equal to 7, the values of the recursive functions for 0 and 4 will be 3400 and 3500. Best recursive function value will be 3500 and corresponding alternative will be 2. So in this way the stage 3 will be completed. Now in the stage 4, all the 4 items will be considered combined. Now in the stage 4, again the state variables will be 0, 1, 2, 3, 4, 5, 6 and 7. allocated weights will be multiple of 3 and which must not exceed the limit 7. So the total weights allocated will be 0, 3 and 6. Recursive function will be allocated weight divided by 3, this 3 multiply by 1400 plus f3 of x4 minus allocated weight. So by using that recursive function, these values are obtained. So the procedure to obtain these values is same as that I have explained in the stage 1, 2 and 3. So best recursive function values are obtained 0, 400, 1000, 1400, 2100, 2500, 3100 and 3500. So these values you can calculate by pausing this video and cross checking. Okay. The various alternatives are 1, 1, 1, 1 and 2 here. The value 1400 is for the alternative 1 and 2 also. So there are here the two alternatives are best one. So similarly for x4 equal to 7, the value 3500, which is best recursive function value, it is for the two alternatives, alternative 1 and 2. Now, once the stage 4 is completed, the next task is determination of the loading of the item to optimize the return value. Now, here, when we see the alternatives 3 and 7, there are two best alternatives. So that means whenever there will be multiple alternatives, multiple best alternatives, so there will be the solutions, number of solutions as many as the best alternatives. So here for x4 equal to 3 and x4 equal to 7, there are two best alternatives. So that means for this particular cargo loading problem, there are two solutions. So solution 1 will be, now for the stage 4, the best alternative amongst the obtained are, so it is with respect to x4 equal to 7 and that value is 3500 with respect to allocated weight 0 and 3. These alternatives are 1 and 2. So out of these two alternatives, first I will consider alternative 1. So when I consider alternative 1, the weight allocation in the stage 4 will be 0. So the remaining weight with me will be 7. So 7 minus 0, it is 7. Okay. Now let us come towards the stage 3. In the stage 3, the best value of return function in that table is 3500 with respect to alternative 2. So in the stage 3, with respect to alternative 2, the best value is 3500. So when we allocate weight 4 ton, this value 3500 is obtained. So 4 ton allocated weight is allocated in the stage 3. So remaining weight with me is 3 ton. So 7 minus 4, that is 3 ton. Now let's come towards the stage 2. Now in the stage 2, now I am having 3 ton weight. So this 3 ton weight, now for this 3 ton weight, the best value of recursive function is 1400 with respect to alternative 2. So with respect to alternative 2, the best value is 1400. So 1400, that value is for the weight which is allocated is 1. So when I allocate 1 ton weight, the remaining weight with me is 3 minus 1 equal to 2. Now let's come towards the stage 1. Now I am having 2 ton weight still. So for the 2 ton weight, I can allocate item 1 with quantity 1. So I can allocate 2 ton weight of item 1. So when I will allocate that, I will get the return of 1000. So this. So when I use this loading policy, the best return value obtained will be 3500. Now similarly, the second solution will be in the stage 4. When I allocate weight 3 ton, the remaining weight in my hand will be 4 ton. So 4 ton, still there is a weight in which I can load item 3, 2 or 1. So in the stage 3, so when I consider weight 4, so I can allocate this 4 ton weight of item 3. So when I allocate 4 ton weight, the remaining weight which will to allocate, it will be 0. So in this way, by following this loading policy, the best optimal return is obtained and it is 3500. So in this way, the cargo loading problems can be solved using dynamic programming. Thank you.